అందుబాటులో ఉంది. ఇటు వచ్చారా?
వాళ్ళు వాడుకోండి. Hello, can you hear me? I'm Professor Anjaneyulu.
Yes, sir. Yes, sir. We'll start in 2 minutes. ఒక్కసారి లీవ్ అయ్యి మళ్ళీ చేయండి సార్. స్పీకర్
The chairman, sir.
స్కానర్ ఇంకా చేంజ్ మనకు షో మీటింగ్ టైం వరకు టీమ్ ఇంతకుముందు పాత విండో వచ్చింది. ఇంతకుముందు మీరు లేనట్టు స్టార్ట్ చేస్తారు. సో కళ్యాణి మేడం కళ్యాణి మేడం ఆర్ యు దేర్?
Yes, sir. I'm here only, sir.
Madam, you can start, madam.
Yeah, sir. Good evening, everyone. This is Kalyani, Assistant Professor from the Department of ECE. It is my great pleasure and honor to welcome today's chief guest and keynote speaker, Professor L. Anjaneyulu garu, and dignitaries, Chairman of Balaji Group of Institutions, Dr. A. Rajendra Prasad Reddy garu, Secretary of Balaji Group of Institutions, Dr. G. Rajeshwar Reddy garu, Principal of Balaji Institute of Technology and Science, Dr. V. S. Hariharan garu, Academic Coordinator, Dr. V. Narayana garu, Head of the Department, Dr. P. Kiran Kumar garu, and the coordinators of this FDP, Dr. V. Madhukumar garu and Dr. V. Karthik Kumar garu, and the faculty participants. I welcome you all for the inaugural ceremony of 1 week online FDP on key technologies enabling 5G, which is sponsored by ATAL and organized by ACE Department BITS. So the 5G, the fifth generation of mobile network, leverages several key technologies to deliver significantly improved performance and capabilities over its predecessors. These technologies include massive MIMO, millimeter wave, network slicing, edge computing, advanced modulation and coding schemes, beamforming, and dynamic spectrum sharing, so on. In this regard, now I request the coordinator of this program, Dr. V. Madhukumar garu, to speak few words on this occasion. Madhu sir, it is not audible.
Respected, thank you, madam. Respected today's chief guest as well as keynote speaker, Professor L. Anjaneyulu garu, NIT Warangal, and our beloved chairman, Dr. A. Rajendra Prasad Reddy garu, Balaji Group of Institutions, and Principal Dr. V. S. Hariharan garu, Dean Academics Dr. V. S. Narayan garu, Secretary Dr. G. Rajeshwar Reddy garu, HOD of EC Department Dr. P. Kiran Kumar garu, and as well as my fellow colleague, co-coordinator for this program, Dr. V. Karthik Kumar garu, and esteemed faculty members and research scholars from various institutions across India. So a very good evening to all. So it's my honor and privilege to welcome you all for this AICTE sponsored online 6 days faculty development program on key technologies enabling 5G. So first, at the outset, I would like to heartfelt my gratitude to AICTE for sponsoring this FDP and providing the facilities to do this FDP. And after that, I would like to thank to our institution, Balaji Group of Institution and management, as well as principal for supporting us to execute this FDP. Actually, this vision of this AICTE has enabled us to meet together to share our thoughts in between collaborate academia and industry, and to discuss about what is happening related to 5G. So this FDP, which focus on transforming power of 5G technology, it is a groundbreaking advancement. Actually, there are eminent speakers which are there in line. So, but I want to mention few points. Most of you are attended ATAL FDP a lot of times, but some of you are attending right now. So it's my customary to tell you about the criteria for getting the certificate. So you need to maintain at least 80% attendance, and whatever the test which we are going to conduct in the last day on 14th. Last day, you need to get 70% in the test. And one more important, once you completed the FDP, you need to submit the feedback with your login portal. So once you done all this, you are going to get the certificate. Wishing you all a fruitful and enriching learning, happy learning. So thank you all.
Thank you, sir. Now I request the head of the department, Dr. P. Kiran Kumar Garu, to share a few words with us today.
Thank you, madam. Respected chief guest, Professor L. Anjaneyal Garu, NIT Varangal, Chairman, Dr. A. Rajendra Prasad Reddy Garu, Principal, Dr. V.S. Hariharan Garu, Dean Academics, Dr. V. Narayana Garu, Coordinator, Madhukumar Garu, and Co-Coordinator, Dr. V. Karthik Kumar Garu, and my dear co-faculty members, research scholars, and participants. I welcome you all to the key technologies enabling 5G. So it is my immense pleasure to introduce myself. This is Dr. P. Kiran Kumar, Associate Professor, Head of the Department, ECE. Our college is established in the year of 2001, located at Narsampet, Varangal, which has a rich heritage and culture. Our college is certified by ISO and accredited by NAC and NBA, and our college has autonomous status. Our department has UG program with an intake of 180. All the faculty in our department are well experienced with an average experience of 8 years. And among all the faculty, 8 are doctorates and remaining are pursuing PhDs. Department has well-established laboratories such as, so we have advanced softwares like mental graphics and advanced embedded boards like ARM boards. So our department has industrial institute interaction with MOUs from various reputed organizations. So we do have AICTE sponsored Idea Lab in our college, and we are playing an important role in Idea Lab, as Tech Guru is converting ideas into prototype and prototypes into products. And we encourage all the students to undergo internships. Right. So we proudly says that our department two ideas have selected for MSME sponsored hackathons and in the last year. So I request you all, please participate actively and gain good knowledge from the well-experienced trainers. And as sir told that, so for this, we require 80% attendance, and everybody should write assessment as well as give the feedback. Thank you all.
Thank you, sir. Now I request the academic coordinator, Dr. V. Narayana Garu, to address the gathering.
Ma'am, I think Sir was not there. If
Sir,
he was
it's
there,
okay, sir. I'll go with that.
Yes, ma'am. Yes.
Yeah. Now I would like to invite the principal of Balaji Institute of Technology and Science, Dr. V.S. Hariharan Garu, to give his valuable speech.
Respected chief guest, and today's inaugural program of this 6 days ATAL FDP. So Dr. Anjaneyal Garu, Professor NIT Varangal, our Honorable Chairman of Balaji Group of Institutions, Dr. A. Rajendra Prasad Reddy Garu, and Convener, Coordinator, and Faculty of EC Department of BITS, and participants from other colleges across India, research scholars. So very good evening to one and all. So first of all, I thank AICTE for sanctioning this 6 days online FDP. So which is on the key technologies of 5G So which is already all of you know that. So we have migrated from 4G to 5G. So to understand what are the features of the technology of 5G, so this 6 days FDP is being organized, and for this nearly 150 participants have registered and attending, and also so we are encouraging the students. So because it is being telecasted live through YouTube also. So I hope many of the students and other faculty who have not registered, because as there is a restriction on the number. So okay, so I request the faculty who are joining, so request their department faculty also to join, and research scholars, and make use of this 6 days long FDP. And in this connection, so we have nearly 13 eminent speakers, and 2 are from outside India, and nearly 40 scholars, faculty have registered from other than Telangana, outside Telangana. So I really thank the Department of ECE BITS for organizing this wonderful FDP. So okay, as it is a online mode, I request, because it is comfortable for everyone, as it's outside working hour, I request everyone and see that it is not merely maintaining a minimum attendance. See that you are attending all the sessions, as it is a comfortable time, and interact with the resource person, and see that you are carrying forward the knowledge to impart to your students in the college. So I thank once again. So I thank our today's chief guest for accepting our invitation and readily, even though he is in traveling condition, but still he has accepted because of his preoccupied work. So I hope all will be making use of this workshop. And even I thank our chairman for readily accepting to conduct this program, and encouraging us to do as many programs as possible. So I thank once again everyone. Thank you.
Thank you, sir, for your wonderful words. Now I request the Secretary of Balaji Group of Institutions, Dr. G. Rajeshwar Reddy Garu, to address the gathering.
Ma'am, I think SAR was not there. You go through that, ma'am.
Yeah, it's okay, sir. Now I would like to request Chairman of Balaji Group of Institutions, Dr. A. Rajendra Prasad Reddy Garu, to give his presidential remarks.
Respected Professor Anjaneyal Garu, good evening, sir. And respected Principal Garu, and respected Head of the Department, Kiran Kumar Garu, and respected other participants. Good evening, everybody. First of all, let me say thanks to Professor Anjaneyal Garu. Instead of saying thanks to other people, and even including the AICTE, which sponsored this program, really, we know you since beginning, sir. You are giving very good support to our college. Really, our college is very thankful to you, sir. And thank you for your for sharing your valuable ideas, particularly towards this very important technology, 5G, and is already there is a lot of research is going on 6G. So this workshop enable all other participants to think ahead towards 6G technologies, and I request all the participants to concentrate over this particular technology and particular workshop, which is very, very useful towards their improving their knowledge, and particularly it's very useful to the research and enabling the communication system to improve, and useful to the community. Thank you, and thank you once again to Anjaneyal, sir. Please suggest and kindly cooperate always, sir.
Sure. Thank you.
Thank you.
Thank you, sir, for your valuable words. Now I request Mrs. K. Madhavi ma'am to give a brief introduction about today's chief guest.
Thank you, ma'am. Good evening to all. Myself, K. Madhavi, Assistant Professor in EC Department. It is my pleasure to introduce today's chief guest, Professor L. Anjaneyulu Garu. Professor L. Anjaneyulu Garu did his MTech from Department of Electronics and Communication Engineering from REC Warangal in 1991 and later did PhD also from NIT Warangal in the area of radar signal processing. During 1991 to 1995, he worked for the Institute of Armament Technology from DRDO and involved in the surface-borne and airborne radar development for military applications. Later, during 1995 to 97, he worked as a senior staff scientist at Hillier Software Systems, Madras, and involved in the development and deployment of strategic software for the performance assessment of onboard fire control and missile guidance systems of Indian Navy's warships under Indian Navy Technical Evaluation Group projects. After spending 7 years in defense research, he joined back NIT Warangal in 1997 as a regular faculty in EC department. Professor L. Anjaneyulu Garu served as the head of the Department of ECE until recently he was professor in the charge of Center of Innovation and Incubation, MUS and IPR cell of NIT Warangal. He has executed research projects from Defense Ministry, ISRO, and also projects on development of virtual reality and mixed reality systems from Ministry of Mines. His areas of interest are computer network, artificial neural networks, and physics systems, microwaves and antennas, electromagnetic field theory, radar signal processing, and communications. During his service of last 25 years at NIT Warangal, he served in the various administrative roles such as professor in charge of Center for Innovation and Incubation, IPR cell, in charge of Internet and Telecom, member of Institute Master Plan Committee, nodal officer of NKN Network, etc. Currently, he is a nodal officer of Rashtriya Avishkar Abhiyan and principal investigator of science communication, popularization and extension of Vignan Prasar under Department of Science and Technology. He led several community service initiations on ICT tools education for the rural health, police personnel, and rural girls, students, etc. Currently, he also professor in charge of engineering projects in the Community Services Projects and Innovation Garage. He is a senior member of IEEE and a member of IEEE Antennas and Propagation Society, Signal Processing Society. He is a fellow of Institute of Engineers and fellow of IETE and life member of ISTE and a member of International Association of Engineers. He has guided 7 PhD students and currently guiding 12 PhD students and 2 postdoctorates in the areas of antenna design and wearable and future wireless application, synthetics, aperture, radar, image processing, underwater communications, etc. He has published about 40 papers in international journals and about 50 papers in the international conference. He is a popular speaker on the science and technology related topics among school and college education circulars. He is a winner of IETE Gold Medal Research Award along with the colleague. He has visited and has an international academic relations with the University of Malaysia, Perlis, Caliph University, Abu Dhabi. Thank you so much for giving this opportunity. Thank you, ma'am.
Thank you, ma'am. Now it's an honor to me to request Professor L. Anjaneyulu Garu to speak few words on this occasion.
Good evening. Am I audible? Yes.
Yeah, it's audible, sir.
Okay. Thank you for inviting me for this talk. Actually, Suddenly I had to travel today. I'm at airport now. Sorry for the small inconvenience that I'm causing to all of you. So I have joined in time. So it's nice that all of you were registered for the talk today. And then this is very much relevant for today's context. And especially for those who are pursuing research in communication engineering, the 5G and associated technologies are upcoming technologies. And for those who are intending to do active research in this area, attending such programs will be immensely valuable for all of you, where you will be learning a lot of techniques and a lot of design perspectives of how the communication systems grow to meet the ever-changing needs and ever-demanding needs of humanity. So the key technologies enabling 5G is a very broad topic, but however, it's nice that you have chosen different speakers to speak on various aspects of 5G technologies. And this being a very small inaugural, anyway, I have to talk an hour more on the evolution of mobile technologies. So therefore, with these few words, I express my gratitude to the organizing committee for inviting me to deliver the keynote talk for this FDP program. Yeah. So once this inaugural closes, I'll resume my talk. Thank you all, and thank you for giving me this opportunity. Thank you.
Thank you, sir. Now I would like to call upon Dr. V. Karthik Kumar Garu to present the vote of thanks.
Thank you, madam. Good evening, everyone. Myself, Karthik Kumar Govinola, Assistant Professor in ECE and Co-Coordinator of this FDP. It is my privilege to propose vote of thanks. I would like to thank AICTE ATAL for accepting our request and providing us to organize 6 days online FDP. I thank today's guest of honor, Professor L. Anjaneyulu Garu, for sparing his valuable time among us. Thank you, sir. I thank our chairman, Dr. A. Rajendra Prasad Garu, for providing facilities which are backbone to us. Thank you, sir. I also thank our principal, Dr. V. S. Hariharan Garu, for gracing the inaugural function. Thank you, sir. I also thank our academic coordinator, Dr. V. Narayana Garu, for his constant support. Thank you, sir. I thank HOD of EC, Dr. P. Kiran Kumar Garu, for his being a part of the FDP. Thank you, sir. I also thank FDP coordinator, Dr. V. Madhukumar Garu, for his initiation and ideas to make this program a successful one. I also take this opportunity to thank our staff for their support. I also thank all the participants from various colleges for their participation. Thank you, one and all. Thank you very much.
Thank you, Karthik, sir. Now I request Professor L. Anjaneyulu Garu to continue this session with his valuable words.
Thank you all. I shall be presenting my screen. Yeah, can you see my screen, please?
Yes, sir.
Yeah.
Okay. Thank you. Just give me a second. I'm just searching for the full screen button. Okay, thank you. Yeah, let's go ahead. Okay. Thank you. And the talk that was assigned today as part of this program is the evolution of technologies from 1G to 5G. I briefly give an overview of these technologies, and towards the end, I'll conclude the main features of 6G. Yeah. Yeah. So we have all these technologies starting from 1G, okay, up to 5G as on today fully deployed, and we are waiting for 6G anytime down the line next 3-4 years. So we shall try to understand how the evolution has happened from the from the beginning. I will just close my video just to save the bandwidth. Okay. So the wireless applications, as you see, ultimately we need a kind of an application for the humanity where you'll be able to communicate with anyone, anytime, and from anywhere. Okay, so this is the dream of the mankind, so that they'll be able to communicate with anyone, anytime, anywhere. Okay, but given the constraints and given the conditions, it's not happening now. For example, when we have a wireless access point nearby or a wireless provider nearby, we'll be able to connect with anyone and anytime and anywhere. But the moment you are away from a particular wireless access point or a wireless provider, then obviously you will feel the pinch of not having connectivity, not able to talk to anyone. And certain times the signal is better, certain times the signal is poor, and somewhere the signal is better, and somewhere the signal is worse. So therefore, these are the conditions that we frequently encountered. But a true wireless technology supposed to give you anyone, anytime, anywhere. Anywhere actually means that anywhere on the globe. Okay, and by anyone and anytime. Okay. So the current wireless technologies that we see here, whether they will give all these facilities or not. For example, if you talk about voice data, or when you talk about video and multimedia applications in various aspects like high definition television or a email or a wireless lines and so on and so forth. And similarly, there are so many other wireless services as well, like warehouse solutions. Similarly, for the vehicles which are on move, whether they can be goods or they can be vehicles that belong to various service provider or any kind of a travel service, whatever it is. There are several wireless solutions for these people as well. And similarly, there are also wireless solutions heavily employed in schools. That is, wireless solution in the classroom and even remote schools, yeah, even as well as the mobile access. For example, in regular classroom teaching, we need to have Wi-Fi connectivity. Okay, but sometimes the Wi-Fi connectivity that we get in regular classrooms can be from a fixed location or from a local area network. But what we need is this kind of a seamless connectivity without dependency on the local LAN. Okay, so that's a kind of a wireless solution that we wanted to have, irrespective of the infrastructure that is available. Similarly, when there are schools and colleges located in the remote places where there is no possibility of network connectivity, still we should have a solution for the people out there to have all the facilities of networking. Similarly, there are also wireless solutions for the people who are always on the move, like stockbrokers, doctors, service personnel, airplane pilots, and so on and forth. So like this, there are various types of wireless solutions that we came across. However, as we see, similarly, we have several wireless solutions required for home. It means sitting at home, you'll be able to get a lot of information from around the world. And similarly, personal and home security purposes. You'll be using wireless technology, especially for home security, whether you are present at home or not. Even from a very remote location, even though you are away from home, still you'll be able to monitor what is happening at your home through the kind of technologies that we have. So therefore, irrespective of irrespective of all these technologies that you have, and you still have some kind of a bottlenecks here and there. And similarly, we have also got wireless solutions for the police and emergency personnel. So if you look at all these different types of wireless solutions that we have as on today, okay, so they all depend on different service providers. Okay, some are internet providers, some are wireless industrial providers, but somehow there is a connectivity that exists among these things so that we are able to enjoy all these wireless services. But now my job is now to explain you in next 40 minutes or so what kind of technologies, how they have evolved. Okay, so as you see on the screen, that this is the typical scenario for the mobile communication purposes. The technology evolution has taken place. 1980s as called first generation to as on today 2020 plus. We have fifth generation in place. Okay. So as you see from this, almost every 10 years, we see almost a new generation of technology that has evolved with and with a lot of benefits that we get in terms of the speed and in terms of the data rates, I mean the speed, and in terms of various, in terms of the delay or latency, in terms of various technological parameters. They are also called the key performance indicators. So we shall just go through some of these technologies very quickly without spending much time. So as you see on the screen, as I mentioned earlier, that 1G is typically a mobile voice communication, and 2G is now efficient voice, which reached billions people, but of course in digital. And then the 3G technology, which came in 2000s and uses various technologies. It focuses mainly on the mobile data, that is internet connectivity. Then subsequently we have 4G, which came up in 2010, and then it essentially is a mobile broadband technology. I'll speak more on these technologies slowly. And then we have 5G, which came in 2020s, which is in place now. So as you see here, it is continuously evolving, and every 10 years almost we see a new technology generation is coming up. And then every next generation has brought out more than 10 times increase in capacity and capability. That's what actually we see here in all these technologies. Okay, so therefore to have the benefits of all these technologies, we have multiple access approaches. So this diagram shows you a snapshot of what is there as on today, applicable for all kinds of technologies that I've talked about so far, starting from 3G onwards. But of course, more specifically for 4G and current 5G, where as you see in the center, we have an IP-based network. It means even though we talk about mobile technologies, but the core network is always an internet. Okay, because of kind of a technology integration that we see from the mobile hardware to the internet hardware. So we mainly depend on the IP backbone, internet protocol backbone, or internet backbone for all these technologies. So associated with this core network, we have got 3G, we have 4G and 5G wireless LAN, and also we have got a digital subscriber loop technologies like broadband technology, okay, and all these things existing. So all these services we get on our mobiles, on our laptops, on our desktops at home, and so on and so forth. So therefore, the figure that you see on the screen is a snapshot of the integration of several technologies as on today, by which we are able to enjoy the voice and data services in all the means. Okay. So as you see here now, as on today, we have got billions of mobile connections, and then more than 25 billion interconnected devices, and then we have got billions of mobile experiences. It means to say that uh, various applications that we see, let it be imaging or a video or cloud data or shopping or online gaming, okay, and or navigation. I mean, any service that you imagine and think of, you have it on your mobile as on today. Okay. Yeah. So therefore, uh, for going further, you have a mobile in your hand, so a device that fits into your pocket. Okay. And then with that device, with all these technologies, you get a mind-blowing performance on all the most advanced computers can give you. Okay. Similarly, you get graphics, which is a wonderful graphics which you have never imagined earlier, on a small screen of 5 inches in your screen. Okay. Similarly, you get a very high quality multimedia with 4K resolution on your small screen, and also you get reliable connectivity wherever you go now. Unlike older technologies now, where we are worried about the lines on our mobile. Okay, whenever we see 4 or 5 lines, that means we have got good signal strength. But whenever you see lines going down as we are moving, we are worried that we are call may be getting dropped, or your mobile experience may get interrupted. But now, due to increase in technological evolution, you don't have to worry about that, and you have the reliable connectivity everywhere, even on the corners of the world. But of course, we are still on the way to improve. And you get broadband speeds of several hundreds of megabits plus speed. And then we also have a very long battery life. Okay. It means as the technologies are improving, research is also extensively working on how to save the battery life. Many times we are worried that whenever we go to remote places where there is a very less connectivity, and you remember, whenever your mobile is trying hard to send the signal, when there is a poor connectivity, your mobile battery drops very quickly. So you are worried. So therefore, people are also working on the long battery life in all these technologies. So it's not only data rate, not only the extensive applications on entertainment and video, but it's also on how to conserve the battery available battery power on your mobile device. So therefore, technology is concentrate in all these aspects. Okay. And similarly, as I mentioned here, it's always connecting fast. It means we have got a very fast streaming and fast surfing of your websites, and then fast upload of data and fast download of data. And similarly, everything gets connected in real time. Okay. And then many of you are already enjoying video calls on your mobile on 4G phone. It means it's a real-time connectivity, as if you and your friend are talking to each other sitting in front of each other. Okay, so that kind of experience that you are going, even though your friend is 1,000 miles away from you. So that's the power of technology that we are enjoying today. And similarly, the connectivity is very reliable. Okay, it means to say that you never worry about the lines on your mobile which shows connectivity going down. And also, you really enjoy the connectivity on the go, even though you are traveling at a speed of 100 kilometers, 120 kilometers per hour on a 4-lane road, still you get a connectivity without any issue. And of course, not while driving, but when you are sitting, relaxing at the backside seat. Okay. And similarly, connect longer. Okay. Connect longer means actually without even plugging in your mobile into a electricity board, your battery will be able to run for much longer period. Okay. Yeah, so this is the kind of a great mobile experience that we are enjoying as on today. It's all because of technologies that have evolved right from 1980s to 2020, from 1G to 5G as on today. Okay, yeah. And so as you see on the screen, that we have mobile first generation, where you have technologies like basically analog in nature. We have technologies like AMPS, that means telephone switching system, then to digital system like a global system for mobile GSM, and then we have got GPRS, general packet radio service, and then we have code division multiple access CDMA1 mobile 2G. So basically 2G is a digital technology, and then moving we have got 3G. I'll talk more about this thing subsequently. Then as on today we have mobile 4G and 5G as well. And then with speeds, as you see here, basically 1G is only analog voice, but 2G has a digital voice and simple data like your SMS, etc. Limited to only SMS, but digital voice. But once you are into 3G, you have got all kinds of imaging, and then we have multimedia data can be sent at higher speeds. Okay. Yeah. I'm sorry. I think somebody is annotating on the screen. We see some lines. I think the organizer should disable annotation. Anyway, let us see. So therefore, now further, as you see that there are several companies like Qualcomm which participated in this evolution of technologies from 1G to 5G as on today. Okay. So again, as you see here, we have the license spectrum, basically, and then frequency reuse concept, and then mobile networks using various types of integrated networks. Okay, so that the technologies from a single base station to multiple base stations organized in various cells, and then finally integrated into a mobile network, and then people could, get into the various services. Okay. So essentially, the mobile telephone system that I have talked about earlier in the 1G, so basically it is called International Mobile Telephone System, worked at 150 to 450 gigahertz. And then we have got second generation mobile phone, 2G, and we have third generation, we have got digital voice and data connectivity. Okay. So as you conventionally see in a typical mobile architecture, cellular network architecture, you see basically a kind of a cell architecture where each base station covers a certain geographical area. And many number of base stations were installed to cover a large area. And typically all these base stations are controlled by what is called a mobile switching center, MSC. And several MSCs are again connected to what is called a PSTN, or a public switch telephone network, which in turn get connected to the internet. Okay. So these mobile switching centers take care of the handing over from one MSC to another MSC while people are on move from one area to another area. So I will not go into more details of this, but I'm only trying to consolidate the various technological aspects of how the mobile cellular telephone network earlier was established. Okay. Yeah. So olden cellular system used to have a basically a mobile system, a base station, and then a master switching center connected to a public switch telephone network, where when the given geographical area is divided into several cells, generally hexagonal in shape. Okay, because that is one thing which can cover without any gaps within the area. But instead of a hexagon type of a cell, if you use a circular area, then we see some gaps in between. But whereas with the hexagon nature of cell, we don't see any gaps in the coverage of the geographical area. So they also use what is called a frequency, can be reused from one area to another area. That way we can conserve the spectrum. Yeah. So then that's how actually your 2G and 1G and 2G systems were earlier managed. Now later on, we have in 2000 a system called third generation came up with the speeds increases from a few tens of kilobits per second to a few hundreds of kilobits to up to 2 megabits per second. So basically, data speeds have been increased from kilobits to megabits per second. This is the technology of 3G, where video calling was made possible in 3G. Okay. So basically the technology is called IMT 2000 technology, where it was possible for us to have a very high quality voice transmission. And then we could get the facility of sending emails from the mobile phones. then able to send fax, SMS, chatting. Similarly, in 3G, we were able to watch TV programs and then watch films, movies, and similarly, we are able to access internet at reasonable speeds. Okay, so this is about the third generation thing. So the essential features of third generation are faster communication, and then high speed web access, and then TV streaming, and then large capacity broadband. And we were able to download typically less than a minute, about a 3-minute MP3 song or a small video clip. Okay, so that's kind of the facilities were offered in 3G. And in fact, 3G has several technologies. It started with what is a standard called UMTS, which stands for Universal Mobile Telecommunication System, and then which has a data service on two specific technologies called HSDPA, high-speed downlink packet access, and high-speed uplink packet access with the 3 Mbps speed. Okay, and if some of you remember, before you migrated your mobile phone technology from 3G to 4G, you would have actually you would have actually seen on your mobile phone that currently you are actually seeing LTE because all your mobile phones use 4G, but earlier you used to see 3G, and sometimes you see H plus plus like that. So that H plus that you see on your mobile stands for high speed uplink access. Okay, and whenever you are in the city environment, you see full 3G, but whenever you are traveling, whenever you are to a bit remote place, you used to see what is called H plus. That means it automatically adapts itself to what is called high speed uplink and downlink access. So, and the technology internally used for sharing, spectrum sharing and access is called CDMA as well as in TDMA. So CDMA and TDMA slot, that means code division multiplexes in time division multiplexes slot. So the data service also known as 1x EBDO, I'll talk more about it, which has actually improved from 3G to 3.5G, where the speeds are increased up to 14 Mbps from your 3 Mbps speed. Yeah. So in fact, 3G has used, in fact, it is a less battery power. Therefore, 3G phones used to run for a longer time. That means if you had charged your phone, it used to run for maybe a few days earlier. And then it has got a capability of digital error checking, increase in the sound quality, etc., etc. And then maybe it has got very less disadvantages, like sometimes weak signal, and there's a possible security issue, which maybe I'll talk a little later. So essentially, your 3G is actually having several radio interfaces or several technologies, combination several technologies like CDMA, and then a combination of IMT multi-carrier technology, and then you have got time carrier, time code, and then we have got single IMT single carrier, and then frequency time with TDMA, FDMA. So all these technologies are together used to make the facilities that I have shown earlier made possible during the 3G technology. So this is how actually TDMA was exploited in 3G, and then this is how a wideband CDMA was exploited in 3G, while providing services to various people. Like in TDMA, each and every base station uses a different time slot, but in WCDMA, all the stations used to operate in the same time, but with a different code altogether, which comes under what is called wideband CDMA technology. So therefore, in conventional CDMA, as you see, we have only data and as well as the data and voice. But whereas in wideband CDMA, you have got voice, data as well as video all together sent at the same time. So that's how actually your 3G has enhanced its capability in sharing video using WCDMA versus your CDMA of earlier generation. Okay. So therefore, as you see here, that from CDMA 2000, which used actually what is called 125 megahertz carrier, it has evolved into what is called a EVDO, that is evolution evaluation data optimized standard, where the speed has been increased from 3 Mbps to almost 14 Mbps. So therefore, there is a forum called 3GPP, third generation, partnership project. This is a worldwide forum which actually standardizes 3G connection. Okay. So therefore, the technology has moved from WCDMA to high-speed packet access from the earlier standard of IS internal system of 95 or CDMA1 of 2G. Okay, so this is how actually the technology enhancement has taken place from 2G to 3G. And as you see in this mobile and in this slide again, it is shown in a snapshot how it has evolved from. It has actually evolved from 1G to 2G. And you see the technologies like what I mentioned earlier, from analog mobile phone systems to digital and analog systems, GSM, GPRS technologies of 2G, then moved on to your CDMA 2000, and then EVDO technology, WCDMA, HSPA plus, and then TD SCDMA, single carrier CDMA. So these are the various technologies that has influenced for us to move from earlier 1G of 1980s to 2G of 2000 era. Okay, yeah, and then slowly again, as you see here, that from mobile of 2G of 0.5 Mbps speed to almost 14.7 megabits per second, where we have voice, data, and video integrated with the speeds of 14 Mbps plus, which is called EVDO, evaluation data optimized standard of 3G, which has got higher speed in EVDO. Yeah, and then so as you see here, EVDO invention, there are several inherent technologies which EVDO has, where the speeds have increased from 3 Mbps to 14 Mbps plus. The main things are, one is a data optimized channel, okay, where data is split into intervals, enabling a single user to get all the resources at one time. And similarly, it has used what is called adaptive modulation technology. It means higher order modulation to get more bits per second per heads of the bandwidth available. So therefore, it has increased the peak data rates. That is one enhancement. And similarly, there is a kind of optimistic scheduling that took place. So therefore, we always have a good radio signal without losing the connectivity. So these are the inherent enhancements, how we could get speeds from 3 Mbps to 14 plus Mbps speed. Okay. So again, as you see here, from CDMA 2000 of EVDO to WCDMA to high-speed packet access, as you see here, the features of CDMA 2000 and the EVDO are combined now with the 3GPP partnership thing, where it has used a bandwidth of 5 megahertz, where within which voice as well as data, video, everything is optimized. Okay. So this is how actually the technological improvement has taken place. Okay. So again, as you see from this slide, again, it's a snapshot how enhancement has taken place from 2G to mobile 3G of earlier days of 3 Mbps to 14.7 Mbps with CDMA 2000 EVDO, and further enhancement to almost 63 Mbps speed using WCDMA and HSPA. Okay. So these are the enhancements that we have seen in 3G. It means we have got 3G and 3.5G and 3.75G. That's how these standards are named. I think I have another slide where it will be shown. Yeah. So again, as you see here, it's a comparison, a single table comparing from 1G, 2G, 2.5G, and 3G. Okay. So 2.5G is actually is later of 2G with TDMA, CDMA, and 3G with CDMA only. But subsequently later on, we have got 3.5G and 3.75G. So as you see in 3G, the starting time is around 2000s. Then it has got intelligent signal processing with WCDMA, and then it has used a bandwidth of almost 5 megahertz CDMA technique, and then cellular coverage is small, small doesn't mean that it covers small area, but small cell organization. That's the meaning. Okay. And then it has dependent on some kind of IP networks. And we have the service is voice, data, and also multimedia. Okay. So you can leisurely go through this slide anyway later. But that's how actually the technology has taken place. So therefore, the market for the 3G as now wireless advertising, then mobile information, business solutions, mobile transactions that we are doing now, and then mobile entertainment, person-to-person communication, and then also there are several other bearer and other services. Okay, so therefore these are the applications and service market that you see in 3G. As you see in this graph, the bandwidth, versus the service value is shown from low value to high value services are shown here, starting from emergency service to mobile banking service, and then mobile broking service to navigation map in 3G, and then video on demand service that you see here at more than 2 megabits per second speed. Okay, so these are the various applications and services you see in the market when the system has evolved from 3G to from the 2G to 3G. So this is a kind of a 3G network architecture you see. It's a technical architecture where how the mobile service providers manage in their network. So basically, we have a ready access network with their own internal nodes, and then we have what is called a core network, which is connected to the backbone, and it has got several gateways, several node called SGSN, GGSN. That means they're all called service nodes, and it is called they all come under what is called packet switch domain. And then they used to maintain different home location registers and visitor location registers, and then mobile switching centers, etc. Okay, so with this core 3G network architecture, we were able to enjoy the digital voice, and then mobility, and then speeds up to 384 kbps and WCDMA, and high speed access up to 71 Mbps, and then image sharing, video calls, and GPS based services. So basically 3G has offered all these services to us. Okay, so basically at this point of time, I would also like to mention that we are trying to use the wireless networks as part of these mobile networks. So where this is a conventional network architecture of a wireless LAN, where we have infrastructure LAN from the core internet, like you're having routers and switches, and then we have wireless access points, and then various mobiles and laptops. This is basically wireless data network, wireless LAN basically. So the mobile networks are married to these mobile networks, and hence we are able to get the high-speed access at all these places. Okay, so therefore, essentially, these are the various technologies that we can see, wireless technologies as well as other technologies available. As you see on the y-axis, you see data speeds, on the x-axis, you see indoor of few meters to long range of up to tens of kilometers, how the technologies and various standards used. Okay, while we have indoor, we have speeds up to 200 Mbps on your wireless LANs, right from 802.15 to 802.11n. And as the distance increases, we have got the technologies like WiMAX 802.16, and similarly, the earlier technology that I've talked about on CDMA 2000, UMTS, and then WCDMA. Okay, so this is the integration of all these technologies by which we are able to enjoy the services, both data as well as voice services. Okay, but however, there are few issues with the 3G wireless system, and of course, we had about 10 years back. Okay, right now we are in 2024 today with full 5G and also 4G. Many of us are weak, but however, we are trying to review the changes that took place. So they found issues earlier on 3G, like sometimes a high input fee. That means we have to pay more money. We used to pay more money, and then of course licensing was different for different service providers, because we used to get services from various service providers, cellular providers like BSNL, and then Geo, and Airtel, Bharti Telecom, Idea. So all these different cellular providers used to charge differently. Different licensing was one issue. Similarly, spectrum issue, and also there were also aspects of electromagnetic radiation. People were worried that the radiation from the mobile phones, radiation from the mobile tower, would have some effect on the health of the human beings. That was also one of the issue that people have feared during the days of 3G. Okay. And also the phones that we carried during the 3G days were bulky. And even though now, even as on today, some of the people use 3G phones, especially in rural areas where 4G services are not available. But the phones used to be a bit bulky, not that smart and that lightweight. And also sometimes, yeah, lack of coverage, and also phones used to cost more price. So these were some of the inherent weaknesses of 3G, which actually made way for 4G technology. Okay, so again, this graph shows you how the data speeds have increased from few kilobits per second to several hundreds of megabits per second from earlier days to 3G. Okay, so as I mentioned earlier, these are the drawbacks of 3G, and hence people have researched and then slowly moved to 4G technology. So, but however, beyond 3G, that is popularly known as beyond 3G technologies, that's why it's called B3G or beyond 3G. Of course, this is about 10 years back terminology where people used to call beyond 3G technology in the earlier days of 4G development. But there was a paradigm shift in the technologies, how they were managed. Okay. So that's how, because of different service providers, they would have different administrative domains. So there's a kind of a heterogeneity was observed in various networks. So a kind of homogeneity was brought in subsequent developments, which finally led to 4G. Okay. So and also beyond 3G network has given what is called a always best connected concept. Okay. So the technologies are researched and they worked out in what is called always best connected. Okay. It means that we get a ubiquitous coverage so that, wherever you go, you get still the good technology. And also the concept of handover, the meaning of handover has changed from what is called horizontal handover to what is known as vertical handover. So vertical handover takes place from one technology to another technology, but whereas horizontal handover is among similar technologies, like how one base station to another base station signals are used to be exchanged. Okay. So therefore, in the always connected concept, allows user to use the best available access network. Okay. It means it is not based on a single network, but best available access network people were able to use. And this is one new wireless technology was designed. So therefore, internet networking became very much easier. Okay. So therefore, as I mentioned earlier, in B3G network, beyond 3G networks, whatever we see now, okay, in 4G or subsequent 5G, okay, they depend mainly on the emerging state-of-the-art mobile devices. And also, we have a kind of a what I mentioned as there with connectivity without any disruption. Okay, even though they move from one network to another network, what is similarly known as vertical handover versus horizontal handover, as I mentioned earlier, it's a new challenge that people could so as you see on the screen now, this is actually a horizontal handover, a base station to base station. But whereas a vertical handover means that conventional cellular network to what is called a wireless LAN. Okay, because wireless LAN technology is different, wireless providers are different. Okay, and a typical base station technology different, providers are different. But however, when you marry these two technologies, when you integrate them, this is called the vertical handover. So this is what actually made possible for the subsequent technologies beyond 3G. Okay. So therefore, now we stepped into what is called 4G technology, which is basically known as anywhere, anytime technology. And and after 4G came, there is a keyword that people used to call what is called a wireless World Wide Web. It's not just www, but it is a wireless www that 4G made possible. So as the major differences once 4G came between 3G and 4G, as you see on the screen, in terms of the data transfer rate, okay, from a few megabytes to hundreds of megabytes, and then the service from broadband to ultra broadband, and then resolution from very low to high resolution, and then several hundreds of megabits bandwidth, and then the download speeds have improved from several tens of megabits per second. So essentially, what made 4G possible, okay, is in terms of a different technology, a different access technology called OFDM, as you see on the screen. So therefore, if you see this table, difference between 3G and 4G in terms of the major driving architectures and in terms of the network architecture, where in 4G, mostly it is hybrid, whereas in 3G, it is a wide area cell based. And similarly, speeds ranging from few tens of megabits per second to hundreds of megabits per second in 4G, and similarly, bandwidth from few tens of megahertz to hundreds of megahertz, and switching from circuit and packet switch to all digital switching, and then access technologies from WCDMA to OFDM and multi-carrier CDMA. Okay, and also all IP network as a backbone instead of conventional IP. So these are the major technological changes from 3G to 4G, by which actually we are able to achieve much higher speeds and access technologies. Okay, as you see here, again, a snapshot of right from your 0G or 1G up to 4G, and various technologies are summarized here, where all these technologies I mentioned earlier, okay, where in 4G we have OFDM and MIMO technologies as a dominant players, okay. Yeah. Okay. So there is a paradigm shift, as you see here. Again, see from this table, which I have shown earlier also. This slide also shows you slowly speeds increasing from few kilobits per second to nearly gigabits and hundreds of megabits per second in 4G. Okay. So therefore, again, as you see here, this is a continuation of one of my previous slides where we have seen up to 3G. Now, subsequently in 4G, what you see here is the technology called long-term evolution and long-term evolution advanced. These are the technologies which made the speeds possible at in fourth generation. Okay, so we have got more data capacity, and the technologies are known as 20. From 3G to 4G LTE, where we have got multi-mode, okay, and where you have LTE, okay, frequency division duplex, as well as time division duplex technologies are being used, okay. So therefore, 4G LTE is the first global standard for mobile broadband, through the entire world. Few hundred of countries have the network established. Um, you so therefore, the 4G technology delivers more data capacity, okay, in terms of connecting faster and wider channels, and typically more number of antennas are used because it's a MIMO technology that has been used, and similarly in carrier aggregation with more data rates, okay, and also connect in real time. So these are some of the capabilities of the 4G technology. So again, as you see, various standards from 3G standards to 4G standards of LTE and LTE advanced. It is similar to one of my earlier slides. Okay. So for all these things, the essential theme is Shannon's theorem, where you see the channel capacity is given by the bandwidth multiplied by number of antennas multiplied by the signal to noise ratio to the base 2, because SN is basically expressed in dB. So therefore, these are the, so all these technologies, researchers are trying to somehow research on improving the channel capacity by means of improving the bandwidth by using various technologies, and similarly improving antennas by using various MIMO technologies, and similarly also reducing the noise level or increasing the SNR by using different types of either antenna in combination with other technologies. So once you have control on the spectrum and number of antennas on the signal to noise ratio, we will be able to get control on the data rate. So this is the essential, theme of all these various technologies. And as I mentioned, the 4G is actually called anytime, anywhere connection. And it's also called as a magic, okay, where mobile multimedia, anywhere, anytime, anyone, and then global mobility support, integrated wireless solution, and also customized personal services. They're all possible in 4G, and hence it's really called a magic technology. Okay. And then there are several advantages of the high speed, and then high speed video streaming and television broadcasting, enhanced gaming, and then these are all the various things that you have in 4G. Okay. So therefore, the conventional capacity bottleneck now has been addressed in this by using this OFDM technology. And the main concept of OFDM is orthogonality of the subcarriers, where you get performance high and then more efficient communication. Okay. In what is called what is known as a multi-carrier communication. And it also uses what is called a spectrum technology called direct sequence spectrum and other spectrum technologies in combination with this. Okay. So you see here a comparison between your conventional CDMA, DSCDMA, as well as OFDM, which is part of your 4G. So here you can see the difference in terms of the communication resource and in terms of what is called the effect of multipath fading, right? Where the multipath fading is tackled in a better way using OFDM. Similarly, other interferences, and then the complexity, etc. Okay, and the peak to average power ratio. Okay, so all these things are better handled in a 4G system. So therefore, now again, a general architecture of 4G shows IP backbone at the network with all the other technologies surrounded by it. Okay. Anyway, I'll subsequently talk more about these things. So again, a typical 4G architecture shows you the kind of a vertical handoff, okay, from the mobile carrier, mobile service provider to other technologies, like wireless LAN, as well as to satellite technologies. Okay, so this is actually called the vertical handover, which is possible uh, in integrating all this. So therefore, as you see this architecture of 4G, and if you remember the architecture that I have shown earlier in one of the slides for a 3G, so the major change here is there is a something called evolved node B between the radio access network, which actually enhances the connectivity to the other networks. Okay. So, however, people still found few drawbacks in 4G as well. One is the essential weakness is the battery life, even though it has improved from 3G to 4G, but however, it's one of the drawbacks. And similarly, the equipment was a bit expensive. So therefore, people have actually, started using 4G, and then there was a 4G implemented everywhere in terms of, for example, in our country, the Airtel and then Reliance Jio, they started implementing 4G earlier. And then the implementation was not, there's a small cell organization where the 4G cells are used to be mounted on the electric poles and the buildings. So therefore, the 4G connectivity essentially was given not through the telecom towers, but through small cells organized on the electric poles as well as on the building. That's how 4G speeds we used to get. Okay, of course, very less from the mobile telephone networks, but more from these things. Now going down, we have got the 5G now as on today. Okay, 5G technology, which came in sometime around 2010s, which is popularly known as a wireless World Wide Web. Okay, and the features of 5G included high speed, high capacity, and then very high definition quality of multimedia and large phone memory, and then various other where we get speeds of gigabits per second. Of course, there are theoretical speeds of 5G, but depending on the your position, okay, if you are stationary, we get almost hundreds of megabits per second speed. But if you are on moving, then at least 100 Mbps is guaranteed. So these are the features of 5G. And then you see on the screen the 4G versus 5G comparison in terms of switching and in terms of service, where we got dynamic information service access along with AI capability, artificial intelligence. Similar data rates have improved up to 1 Gbps. Actually, the technology is used a combination of all kinds of local and LAN, WAN, as well as wireless LAN technologies are used along with World Wide Web. And there is a single unified standard for 5G and multiplexing used as CDMA, enhanced CDMA, and other technologies. So therefore, as you see, we have got experience with 5G implemented as on today everywhere. Now almost as on today, we have got more than 2 billion connections of 5G worldwide. Okay. And it is fully deployed. It is available everywhere. So as you see on the screen, right from 1G to 5G, okay, in terms of the year of deployment and how the bandwidth have increased from few kilobits per second, gigabits per second here, and how the technology evolved from analog cellular to wireless World Wide Web, and how multiplexing started from simple FDMA to CDMA, and core network from public sylvia network to the core internet, and similarly dynamic information access. So this is essentially way the technology has improved. And of course, when you map the network architecture to your OSI network layer OSI architectures, then we can have the meaning of application layers, and then open transport protocol and upper layer protocols. But anyway, I will not go into more details, but I just want to show you how these are different. And coming to the architecture of 5G vis-a-vis 4G that I've shown earlier, and essentially this uses what is called physical layer data link on the 5G networks are based on this. Okay. Sorry for the interruption. And then, going further, the 5G core hardware involves, several other networks, and then it uses CDMA, and also the software of 5G uses all kinds of software related to the previous networks which I have shown. Okay. So essentially the features of 5G, as I mentioned earlier, high resolution video, and then bidirectional bandwidth, less traffic, and then minimum 25 Mbps connectivity. That means lowest of lowest. But however, you have 100 Mbps speed even on your move, and then better and fast solutions, and then uploading and downloading, which usually touch a peak data rate of 1 Gbps. Okay. Of course, there are several advantages of 5G. Okay, because bandwidths are more than typical Gbps, and then available at low cost, and then we get very finest quality of service because of the highest quality of this service available. And then we have got high speed multimedia, voice and streaming video available. Okay. And then and further, not only this, the 5G also includes some other additional capabilities where we have got the integration of wearable devices with artificial intelligence connectivity capability. So therefore, the 5G has a capability of extending its connectivity to several wearable devices where the body communication is possible. Body to body communication is also possible. Okay. And some of the higher end devices also have some kind of sixth sense technology at very elementary level included in them. Similarly, we have a global networks, and then voice over IP, VoIP enabled devices, and then we have integrated radio resource management and media dependent handover. All these are the features of 5G by which now, it's fully deployed. So this is the architecture of 5G mobile network. And then where you see, a kind of upward compatibility from upward compatibility and as well as downward compatibility depending on your position. Okay, so essentially the elements of 5G, as you see here, are the key performance indicators. We have got converged platform, more secured platform, and unified spectrum, and then scalable network architecture, fast deployment, and then more battery life, and ultra reliable, and low latency of few milliseconds, and then very large coverage capacity, and then very efficient networks, very less operational and capital expenditure, capex and operational expenditure. So these are the essential, elements of 5G, which made this possible. Okay. So therefore, the key performance indicator, as I mentioned earlier, are shown here. So essential key performance indicator is the battery life. Okay. And it means to say the battery goes for several days with one charging. And then these are essential features of this one. And then further technically, if you see here, in 5G, latency is less than 1 millisecond guaranteed. And then, latency in the air link. Similarly, latency end to end is less than 10 millisecond. Similarly, connection density. Okay, that means number of connections. Similarly, you have got area capacity density, and then system spectral efficiency. All these are the expected parameters of 5G. So the essential features are: one is enhanced mobile broadband, and then ultra reliable low latency, and then you have massive machine type communication. These are the essential features of your 5G, where today it is possible, and already they are deployed. Okay. So of course there are few challenges in 5G as well. Okay. In terms of new waveform design, in terms of massive MIMO and millimeter wave technologies being used in 5G. Similarly, different channel models are employed, and then advanced receivers are designed. And then these are the various challenges and solutions by which now 5G is made possible. Okay. So therefore, the scope of 5G is now further into virtual and augmented reality. Okay, are being integrated slowly into 5G networks, and autonomous driving, autonomous vehicles. 5G is now integrated. Vehicle to everything, that is V2X communication is possible. Internet of Things, industrial Internet of Things possible. So these are the features of 5G. Now in the upcoming days as well, we are going to have a 5G plus and 5G plus plus. Okay. So by 2025, we have actually 5G plus will be happening next 1 year. 5G plus is already, prototypes are being ready, is made ready. And then from 25 to 20, by 2028, 5G plus plus will be ready with the what is called a 5G enhanced technology, or IMT 2020 enhanced technology. Okay. So 5G advanced technology will slowly lead into 6G technology. Okay. So there is a inherent so therefore, the 5G network architecture is something similar to this. 5G NR stands for 5G new radio standard, and then we have a next generation radio access network and 5G core networks. Of course, I am not showing more details here, but this is a kind of a technology architecture available for 5G as on today, where we get connected virtually, including machines, objects, and devices. It's not only a mobile phone to mobile phone communication or mobile phone to network communication, but 5G means that it is a connectivity between machines, objects, as well as devices. So that's actually 5G means. Now 6G actually includes human beings as well. Okay. So that's how we should remember. So in addition to machines, objects, devices, and networks, if human beings are connected, that becomes 6G technology. But as on today, we have this communication is possible now. It is happening between machines, objects, and devices. Okay. So therefore, inherent weakness in this. So therefore, as on today, as I mentioned earlier, so the inherent weakness in 5G, if at all somebody wants to point out any weakness in 5G, it's only a latency and it's only about spectrum. Otherwise, there are no other weaknesses as well as on today. But both are improved in 6G. Latency is improved and spectrum is also improved. So therefore, this is the status of 5G deployment. So as on today, we have got more than 2 billion 5G global connections. In India, we have about, I think I have in next slide. By 2025, 5G are likely to cover 1/3 of world population. That's expectation. But now as on today, almost more than 120 countries have the 5G deployed in all of them, and they are using 5G technology. Okay. But by 2025, next year, it is supposed to be covering almost 1/3 of world population. So this is a typical 5G map, the latest 5G deployment map of 2024. So whatever you see in pink color, it means in all these areas 5G is fully deployed. Okay, but in India, if you see in 5G, of course, it started in October 2022. 1st October 2022 by Prime Minister in the International India Mobile Congress. But as on today now, in next 2 years, from 2022 today and 2024, so in this 4 years after launch in India, we are now have almost 130 million users are connected to Jio's 5G network and about 90 million on Airtel 5G. So therefore, as on today, it's almost 130 million users on Jio's 5G network in India. Okay, and of course, it's going to rise so Jio and Airtel are the major network partners for 5G in India. But as on today, the status is we are 130 million users connected to 5G. Okay. Now, I think I'm going to conclude my talk in next maybe 5 minutes maximum. Now, slowly coming into 6G. So what is 6G now? Okay. So 6G is actually truly omnipresent wireless intelligence. Okay, it's not just a wireless connectivity, omnipresence of wireless connectivity, but it is called wireless intelligence. Okay, so suppose it's expected to be available by 2030s, where 6G may become reality. Okay, so therefore 6G it doesn't talk only about data and latency and other applications, but it also use cases covers e-health for all on the globe. Similarly, precision healthcare, smart agriculture, and various digital twins, cobots, robot navigation, several things that we are going to see in the upcoming 6G technology. Okay, so therefore there are 3 broad scenarios. Okay, one is called Internet of Senses. Okay, it means all the human being senses like our touch, and then vision, and then hearing, and then taste, okay, and then vision. These are all the 5 senses. Okay, so therefore we are going to have a technology now. Okay, 6G technology, which is available on your mobile device, which connects to our all 5 senses as well. That's why it is called Internet of Senses. Okay, and also the connected intelligent machines and connected sustainable world. So these 3 are the broad scenarios which are going to be covered under 6G technology. Okay, Internet of Senses, connected intelligence machines, and connected sustainable world. So therefore, the 6G market is expected to facilitate, areas like imaging, presence technology, and location awareness, so on and so forth. So therefore, we expect a sustainable, higher capacity networks in the upcoming years. So from 2028 to 2030, earlier 2 years, we are going to have some prototypes because research is being done already. Okay. So 6G, these are the use case scenarios of 6G. As you see on the screen now, from IMT 2020 standard of 5G, we have now 5G advanced to 6G now, which is now supposed to be IMT 2030 standard. So from enhanced mobile broadband to immersive communication, from machine type communication to massive communication, from ultra reliable low latency to hyper reliable low latency. So these are the things which come under what are called 5G advanced, which now lead into 6G by 2030. Okay. So therefore, as you see here, use case scenarios are integrated sensing and communication, and then ubiquitous connectivity everywhere, and then integrated artificial intelligence and communication. Okay. So all this will give me immersive communication, massive communication, and hyper low latency. So these are the use case scenarios of 6G now down the line. We have to wait for another 6 years. Okay. So because of this IMT 2030 standard of 6G, now 6G is going to come up with 9 enhanced capabilities compared to 5G, and then there are 6 new capabilities compared to 5G. So the enhanced is that we are going to enhance security, and reliability is going to be enhanced. Latency is going to be enhanced from 1 millisecond to less than 1 millisecond. And then, mobility is going to be enhanced to, several thousands of kilometers. And then connection density is going to be enhanced. And then area traffic capacity is going to be enhanced. Spectrum efficiency is going to be enhanced. And then user experience is going to be enhanced. And peak data rate is going to be up to several gigabits per second. So these are the enhancements compared to 5G that we expect by 2028. And then the new capabilities, which were not there in 5G, are one is the global coverage, and also coverage beyond globe. That means coverage even to the air, and other possible, UAVs, okay, that are flying above the Earth surface. And then sensing capabilities and artificial intelligence related capabilities, and then sustainability, interoperability, and then positioning accuracy. Okay, that means your GPS accuracy may go even less, even up to a few centimeters on your screen. So these are the capabilities of 6 that we're going to enhance. So ultimately, what we are going to have, what is called a virtualization and mobile cloud, and a convergence of all these technologies. Okay, and we are going to have now thing.
Sir, you are not audible.
In trying 6G. In fact, this particular talk can go to several hours if I go into details of each and every of these several generations of technology. But however, I limited myself, to very basic, thing, and hence I have limited my discussion to major features. Okay. So thank you all for your patient hearing. And then I'm just stop sharing my screen, and then I'm open to any few questions that if you have any that I can answer, and then possibly close the session for today. Okay. So thank you all for your patient listening. Thank you.
Thank you, sir. Thank you so much for such an insightful and engaging session. So your expertise and knowledge have truly enriched our understanding of the evaluation of 1G to 5G. Even you have given futures of 6G also. Thank you, sir. Thank you so much. So participant, any questions? Sir, as you are in traveling, can we take, sir, questions right now?
Fine. Yeah. Fortunately, see, actually, I'm actually not traveling. I just, stationed at some time in my car, somewhere near the airport. So the network supported me very good.
Sir, yes, sir. Yes, sir.
So, yeah. So therefore, I'm able to, talk to you in real time, interact with you in real time, thanks to the 4G network. I'm still using 4G only. I'm not yet migrated myself to 5G yet.
Sir,
Yeah. Yeah.
sir. Participant, please, if you have any questions, kindly ask. Okay, sir. So I will share your mail ID, sir. If they have any queries, they will drop a mail to you, sir.
Yeah.
Thank you, sir. Thank you
Yeah,
so
yeah,
much.
yeah.
Kalyan, madam, please
Yeah.
give the concluding remarks.
Yeah.
Yeah, thank you.
Sir, I would like to express a heartfelt thanks for your insightful presentation on 5G communications and their technologies. Once again, thank you, sir, for your inspiring presentation. Have a great day, sir.
Thank you all. Bye bye. Yeah.
Thank you, sir.
See you again. Yeah. Yeah.
Sir,
Thank you. So if you all permit me,
sir, actually,
I log out.
Sir, actually, Professor Mode Master from Qatar University also there, sir.
Yeah, I can see. I can see on the screen. Yes.
Sir.
Hello.
Yes.
Yeah.
Good afternoon. Good night. Okay,
thank you
let me
very
share
much.
my slide.
Sir. Okay.
So I log out and thank you all.
Yes, sir. Yes, sir. Okay, sir. Thank you, sir. Thank you so much. So, I request Kalyani madam to introduce session to speaker. Ma'am, over to you.
Yes, sir. Sir, a very good evening to one and all once again. Professor Modemo, a fellow of IET, received his PhD from the Department of Computer Science at the Hong Kong University of Science and Technology in 1999. Professor Ma is a research professor at the College of Engineering at Qatar University. He has extensive research interests, including network security and wireless networking. He has over 520 international academic publications, including more than 260 journal papers and over 250 conference papers. His publication has received about 12,000 citations in Google Scholar. Professor Ma currently serves as the editor-in-chief of the International Journal of Computer and Communication Engineering and the Journal of Communications. He also serves as a senior editor for IEEE Communication Surveys and Tutorials and an associate editor for the International Journal of Wireless Communications and Mobile Computing and the International Journal of Communication Systems. Professor Ma is a senior member of the IEEE Communication Society. Professor Ma has been a distinguished lecturer for the IEEE Communication Society from 2013 to 2016 and from 2023 to 2024. Sir, we are truly grateful for your time and contribution towards our FDP. We heartfully welcome you, sir.
Okay, good afternoon, everybody. And thank you for the introduction by the chair. As introduced, my name is Model Ma from College of Engineering, Qatar University. And my email and website as shown here. The topic I would like to deliver today is on the security enhancements for 5G wireless network. First of all, let me introduce the architecture of the 5G wireless network, and followed by the introduction of the vulnerability and threats to the 5G wireless network, and then show the motivation of our research work. Then we have two examples of the enhancements to show that how to enhance the security functions of the 5G wireless network. After that, I have recommend some open research issues in the field of the 5G security. At the last, the conclusion. So 5G wireless network becomes a major carrier for wireless communications that could support Internet of Everything and large-scale heterogeneous connections. 5G wireless network present many promising and advanced features. The recent standard made by the third generation partnership project is the TS 23.501 release 16 as the standard to specify the architecture and various functions of 5G wireless networks. So that based on this standard, there are a lot of 5G wireless networks have been deployed in many countries like Qatar. This is the situation of the development of 5G wireless network. Now let's look at the overview of the architecture of the 5G wireless network. In this blue area is basically the 5G core network. Basically, it provides different supports and functions to support wireless access network. While the small cell is the 5G wireless access network. You can imagine there are a lot of such cells to compose as the wireless access network supported by the 5G core network. So in the wireless access network, the major player is the G node B, or next generation base station. In each cell, there is a G node B, while there could be many user equipments, which are supposed to be the mobile phones, which support 5G access, or which have 5G interfaces. This is the architecture. And we can see that 5G wireless network, from this architecture, we can see that the 5G wireless network consists of the core network and the radio access network, with many cells surrounding the core. A 5G radio access network consists of G node B and user equipment. A 5G core network consists of many network functions, such as access and mobility management function, AMF, session management function, SMF, user plane function, UPF, authentication server function, AUSF, authentication credential repository and processing function, ARPF. There are a lot of other functions. However, these 5 mentioned functions are supposed to be the functions relevant to the security function in the 5G wireless network. Basically, those functions are supposed to be implemented by different servers inside the core network. So now let's look at 2 operation scenarios in 5G wireless network. Same thing, we have the 5G core network. The first scenario we are going to discuss is the handover scenario. What does it mean? Handover will happen when the user equipment moves from one small cell to the other small cell, which is supported by another G node B. So that, in fact, in 5G wireless network, there are 2 types of handover scenarios. One is intra-AMF handover. We can see from this diagram, one AMF can support many G node Bs in the neighborhood. While in the 5G core network, there could be many AMF like this one. One is here, the other one is over here. So intra-AMF handover says that a user equipment moves from the cell supported by this GNOB to the other cell supported by another GNOB. However, these two GNOBs will only supported by one AMF, so that handover happens within the supporting coverage of one AMF is named as intra-AMF handover. The second type of handover is an inter-AMF handover, which means that one user equipment may move from the current cell to another cell where this cell has its GNOB supported by second AMF, another AMF. So that this type of handover is called inter-AMF handover. AU handovers between different GNOBs over the control of different AMF. So this is one scenario in the 5G communication. The second scenario is device-to-device communication. So there could be three types of the operation in the D2D communication scenario. One is in coverage, which means that if the two devices are going to communicate each other within a cell, which is named as in coverage D2D communication. While the second type of the D2D communication is that one device is inside the cell, while the other device is out of the cell. So that this type of D2D communication is named as a relay coverage or partial coverage D2D communication. The third type is the two devices are out of one GNOB or coverage, so that these two devices can communicate to each other without any support from the GNOB in the neighborhood cell. So as I described over here, there are three types of the D2D communication. So in coverage mode, all D2D user equipments are under the communication coverage of GNOB, so that this kind of D2D communication will get support or will get the full support from the GNOB. In the second type, partial coverage mode, some D2D devices are out of the communication coverage of the GNOB, while the user equipment can only get the support from the GNOB partially. While the third type, all devices are out of the communication coverage of GNOB, so that the D2D communication will only be handled by user equipment independently without the support of the GNOB. So this is the architecture of the 5G wireless network and the two types of the scenarios of the operation of the 5G communication. While we further look at the threat to the 5G wireless network. So the security threat to the 5G network is basically coming from the radio access network. Since radio access network to have the connection wirelessly, so that the wireless communication is very easy to be attacked by attackers. In a core network, all the devices or functions are connected by the cables. So normally, the core network will get less support, less threat from the attackers. One possible attack is that the passive attacks to the AMF. While this passive attacks is coming from the intervene of the communication over the cables. While in the wireless network, different types of threats or attacks will affect the wireless communication inside the radio access network. It's possible for the attacker to break the communication between the two D2D communication and break the communication between user equipment and the G-Node B, and so on. So in 5G wireless network, particularly in wireless access network, the threat happens very often. One type of the passive attack is eavesdropping, by which a passive attack can intercept the communication channel to get data between two user equipments, or the control message between the user equipment and the core network. So that this eavesdropping may happen everywhere in the 5G wireless network, particularly inside radio wireless access network, while it's also possible to happen in the core network. The second type of attack is impersonation attack. Attacker can pretend to be another user to get access to the network. This is supposed to be active attack. The third attack is a data fabrication attack, which is an active attack, which create the fake information in order to manipulate other users' equipment. Data modification attack, which is also an active attack to change the data set from a specific user to faithfully specify other users. Then jamming and denial of a service attack. Attackers can deliberately disrupt or block the connection of normal users in the network. Particularly in a device-to-device communication, the first type of attack is a privacy violation attack. D2D services will have device discovery. While in this process, the attacker may get the identity data so that the attacker can trace the device by continually sniffing D2D broadcast. Free riding attack. Some selfish users only receive contents from others but refuse to help others relay data in order to save energy or computation capacity. The availability and service quality of D2D network will be affected by this kind of selfish action. In fact, it is not particularly attack, but it is a selfish actions. Location spoofing. Active attacker may send out malicious location information to confuse existing D2D users or even disrupted D2D group forming. So those are the possible attacks in operation of the 5G wireless, particularly in the handover scenario and D2D communication scenario. So we have mentioned that currently the 5G wireless network has been standardized by 3GPP committee to ensure various network scenarios to meet the security requirements. Many security solutions have been deployed to enhance the security functionality against the various malicious attacks. However, either the issue of network performance or the issue of security functionality has been ignored without a comprehensive design to achieve a trade-off between them to meet the various requirements of different applications. Therefore, we have the motivation to design and develop novel, efficient, secure solutions with the aim to protect 5G wireless network for sure and efficiently in various network scenarios. The philosophy of this research is to achieve a balance between the security functionality and the performance of 5G wireless network. So with this aim, we have designed two types of security scheme. One of them is a lightweight and secure handover authentication scheme, LSHA, to secure handover processes in 5G wireless network. LSHA has the following features. First of all, LSHA can achieve key forward secrecy by using a message authentication code with the ability to prevent denial of service attacks and desynchronization attacks. Secondly, the LSHA integrate the concept of cellular networks with the neighborhood graph, by which the process of encrypting next host will be limited to the neighborhood genomes and the current servicing genome. The LSHA scheme has a renewal policy to pre-share the keys to prevent key leakage to some extent. The proposed scheme has a much lower delay performance compared to other existing schemes. The second solution is named as lightweight traceable D2D communication, authentication, and key agreement scheme, which is designed to support the D2D communication to prevent the attacks in the D2D communication process in 5G wireless network. ATA can improve the security in the most scenario, particularly in open device discovery and one-to-one direct communication scenarios. It has the following outstanding features. First of all, privacy-preserving device discovery, which means in the process of device discovery, the user information will be kept private and will be kept private. Device anonymity, which means that the name of the information of the device will be kept secret. And mutual authentication and key agreement, which is the general function of the authentication protocols. And session key FS, key forwarding secret will be able to be implemented, and message non-repudiation function will be available. Particularly, this ATA is able to resist to some typical attacks, including eavesdropping, man-in-the-middle attacks, replay attacks, particularly free-riding attacks, which we mentioned that it is a special in the D2D communication, although it is not attack, but selfish actions. The unique security function is a free-riding attack prevention. It is a selfish behavior in D2D communication. Some devices connect to others to obtain information from others while refuse all the incoming connection to save the energy and the bandwidth. Availability of a D2D network will be severely impaired. But with the LTAA protocol, the system can trace and detect possible free reading users' equipment. Will be deter free reading effectively by blocking selfish user equipment. Now, these are the, until now, we have mentioned the security issues in a 5G wireless network, particularly in two operation scenarios. One is the handover scenario, the other is a D2D communication scenario. Now we are going to look at whether there are some other research issues which can be further developed, investigated in the near future. First of all, in the handover authentication issue, there will be an issue of massive devices. The handover authentication for massive devices is required because when we talk about the handover authentication previously, including all design, we only target one device or one or two large device to perform handover authentication. Now, the problem is that how to make authentication for large amount of devices in a cell. Secure handover authentication for massive devices are required to support high-speed mobility, particularly in a high-speed train that in a carriage, lots of passengers in the train, so that they are supposed to get handover quickly at the same time. The second issue is that the confidentiality and the integrity preserving is required in the design of the security schemes. They are required to ensure the confidentiality and the integrity of sensitive data in extremely high speed transmission, so that those are the requirements to protect the sensitive data, which are not going to be published or leaked to the others, including the normal users. Universal solutions are needed. Universal security devices, the discovery, secure access, mutual authentication, and key agreement protocols for heterogeneous communication in 5G wireless architecture are required. The reason is that in 5G wireless net, different type of heterogeneous communication technologies will be supported, which means that not only the communication technology supported by 3GPP in the 5G will be supported, but also 5G wireless network needs to support different types of communication technologies, including 4G LTE and wireless LAN and so on, and some others, because 5G are currently used to support the Internet of Everything, so that in such a scenario, different types of communication technologies are needed to be supported by the 5G or wireless network umbrella. Another point is that the 6G wireless network will come out soon. Although there's no standard to specify the 6G wireless network architecture, including the security issues, but it will be a problem. Security in 6G wireless network includes the security concerns of massive handover, massive data, and heterogeneous communication too, to consider, because the 6G will have even faster speed than the 5G wireless network. Okay, those are supposed to be the potential research issues in the near future to deployment, to further deployment of 5G wireless network. So I think this is the last slide of my speech. So in this speech, we have simply reviewed 5G wireless network architecture with the various network scenarios specified by 3GPP specification, technical specification, which is a TS 23.501, release 16, which is supposed to be major standard currently at this moment. Of course, the standard development process is still ongoing, but this standard is supposed to be a major one to be used by many, to be followed by many manufacturers. The security requirements of 5G wireless network has been described with the exploration of the security vulnerabilities and potential malicious attacks, and then followed by the motivation of our research work on security of 5G wireless network has been discussed. Furthermore, we have provided two security solutions with the aim to enhance the security functions as well as the efficiency of the network, as the examples of our current research work. At last, we have discussed some potential research issues on security of 5G, 6G wireless network, with the aim to promote potential collaboration on the academic research in the field of security of 5G wireless network. Okay, I think that's my presentation. I'm not sure whether you have any questions. You are welcome.
So,
Any
dear
questions?
participants, if you have any questions, kindly ask.
Any questions?
Sir, actually, if they ask any question, definitely I'll forward it to you, sir.
Okay.
Thank you, sir. Thank you so much, sir. On behalf of our institution, I extend my heartfelt gratitude to you, sir, for delivering such an insightful session on security aspects in 5G. Sir, actually, it was an absolute privilege and honor to you have as a speaker for our FDP, sir. Even though if you are very busy, despite of your busy schedule and commitments at your university. So thank you, sir. Thank you for accepting our request. Once again, and thank you, sir, for taking part in this.
Any questions from you?
Any questions, sir? Actually, sir, My side, actually, I'm working on, sir, hybrid beamforming, sir. Sir,
Okay.
with the help of hybrid beamforming, so we are interested to get the better data rate and providing service to more users, and we are looking at energy efficiency also, sir. So how we can incorporate AI in achieving better energy efficiency or spectrum efficiency, so that we are looking right now, sir.
Okay. Anyway, if you have any questions in your research work of network security, you may contact me. Not only necessary to be 5G wireless network security, but any kind of
How can we
network
incorporate
security issues. You may contact me for the collaboration.
Sure, sir. Sure, sir. Thank you, sir. Thank you so much, sir.
Then you specify the problem in detail. We can discuss over the internet to get possible solutions for the promotion of the academic research.
Sure, sir. Sure, sir.
Okay. If you don't have any questions, let's keep in touch. And I have my contact over here. So any questions or any collaborations may go through this email to contact me.
Sure, sir.
Even
Sure,
you
sir.
have any questions, then you can also send your question over this email for the discussion.
Sure, sir. Thank you, sir. Thank you so much, sir.
Okay. So if there's no question, let me quit.
Sir, sir. Thank you, sir.
Okay. Bye-bye. Bye-bye.
Bye, sir. Bye, sir. Thank you, sir. So, participants, actually, we are going to share session 1 and session 2 link. Karthik, are you there?
Yes, sir.
Yes, sir. So, dear participants, some of you are leaving. So, actually, attendance will be considered those who attending for this FDP in Zoom. But due to some network issues, some could not join during that session where we are going to take attendance. That's why we are sharing Google Form link for attendance. So, within few minutes, Dr. V. Karthik will share that link in your group. So, kindly update it. Kindly mark your attendance. Okay. So thank you all. Meet you tomorrow at 6:30 p.m. Thank you everyone. If you have any queries regarding this FDP, you can ask me. Otherwise, we will wind it up.
Sir, please share the session content if it is possible.
Sure, sir. Sir, actually, we are live streaming, sir, it in YouTube and Facebook. So you can, with the help of that link, you can find it, sir. It will be there tomorrow, also from tomorrow onwards, sir.
Today's link we not received.
Actually, today, we unfortunately we could not share it, sir. So after this, I'll share it, sir. And every day at the time of live is going on, session is going on. At that time, we will share that live link also, sir.
Okay, sir. Thank you.
Okay, sir. Thank you, sir. Okay, participants, kindly mark your attendance. Thank you, everyone. So if your friends, some of you are unable to join this WhatsApp group, so kindly share this WhatsApp group link to them. Already I have sent through mail to everyone, but some of you are not typed some type grammatical or typing mistakes were there. Okay. Thank you.